So when we look at this here, this is one of the first ones we're going to look at with using completing the square. Now, we've done completing the square. We did it twice yesterday. Now, this one here is going to work out a little bit interesting, and we'll see why here in a minute. So we're going to use completing the square to solve this one here. So the first thing we need to do in completing the square is see, is a equal to 1? And when we're talking about a, we're talking about the number in front of x squared. So looking at this here, is the number in front of x squared equal to 1? Well, yes, okay. So that's good. That's what we wanted to have happen. Now, the next step is to get the constant terms or terms by itself. So anything without a variable we want on one side, and everything with a variable we want on the other. So for us here, we would subtract 64 from both sides. But 64 minus 64 would cancel out. And we're going to leave 2 blanks. And 100 minus 64 would give us 36. So we moved the 64 over because we want to get the constant terms by itself, because that's what we did yesterday. We did some of this yesterday. And the reason we're moving it over is because I want to have a perfect square trinomial. I want to be able to rewrite this here as a set of parentheses squared. That's our goal. That's what we're trying to do. Because if I can do that, then we can square root both sides. So before we can do that, we need to find the value of c, which is b over 2 squared. So looking at this problem here, what is the value of b for this one here? It would be negative 16. So we'd have negative 16 over 2. Well, negative 16 divided by 2 would be negative 8, yes? And what is negative 8 squared? It is? 8 times 8 would be 64. So we would put 64 here and here, yes? That's the same number as what we started with. It means that this here is already a perfect square trinomial. So if we were able to notice that x squared minus 16x plus 64 was a perfect square trinomial already, we could have skipped all of these steps and gone straight to this here. But if we didn't see it and we don't notice that, doing these steps doesn't change anything. It still works. Because what we'll have inside the parentheses is x minus 8 equals 100. X minus 8 equals 100. And we get the minus 8 because it was what was inside the parentheses. And we were finding the value of c before we squared it. Any questions on this here so far? And what do we need to do next? We need to square root both sides. Can we take the square root of both sides? Well, the square root and square will cancel, leave us with x minus 8 is equal to plus or minus 10. Remember, anytime you take the square root of both sides, we have to have the plus or minus. We have to have the plus or minus. And last but not least, we need to add 8 to both sides. When we add 8 to both sides, we get x is equal to 8 plus or minus 10. Any questions on any of this here so far? Any questions on anything we've done so far? Now, one thing we always need to check on once we get x by itself, can I do 8 plus 10 and get a number? Can I add 8 and 10? Can I subtract 8 and 10? So if I can combine them, we're going to need to combine them. Well, 8 plus 10 is 18. 8 minus 10 would be negative 2. And those would be our two answers. Those would be our two answers. Any questions on this here? Any questions over anything we've done so far? So, are we good to move on to, are we good with this here? Or, I'll write this over here. Actually, I'll give it a second. I'll show you some of the answers that we really can't combine. So, some of the answers we really can't combine would be x is equal to 2 plus or minus 3i. Because these are not like terms. 2 and 3i are not like terms because the 3i is our imaginary parts of the complex number. So we can't combine these. Now, for big idea math, it's going to give you most likely 2 blanks to fill in if it's doing that. It's wanting you to split those apart to have the positive and negative case. Or we have to split the plus or minus up for both of them. On the test, I will take the plus or minus form. I will take that as the correct answer because it is. But big idea math, if it gives you 2 spots, you've got to split those cases apart. Another case would be something like 3 plus or minus the square root of 7. Well, the square root of 7 or any square root that can't simplify, we just leave it as this here. Because we're not really adding 3 to the square root of 7. It would have to take the square root of 7 as a decimal, whatever the decimal form would be, which is going to be somewhere between 2 and 3. And we would add that to 3. Does that make sense? Stormy, find the square root of 7. So this here is what we'd have to turn it into so that we could add and subtract it. We couldn't just add and subtract 3 square root of 7. Because we can't add and say it's 3 square root of 7 and then the other. Does that make sense? So we'd have to turn it to a decimal, and then we're just approximating. This here is a better version of the answer. Does this make sense here? Yes? So we're not going to do this one here, but this one here, well, we'll do this one, but I'm not going to do all the same steps. Because is 9 a perfect square? Yeah. It works out if I factor this here. Well, since it's positive, these are both going to be negative because the constant term is positive and the sign of the middle term is negative. When the constant term is positive, the signs are the same and they match the sign of the middle term. Factors of x would be x and x. And the factors of 9 that match up would be 3 and 3. Or really, we're saying that it's x minus 3 squared. It would work out to be this. Now, would it be wrong to do the same steps that we did with the first one? No. We could have subtracted the 9, found the value of c, which would have been 9, added it to both sides, and simplified down. Does that make sense? So if you don't notice that this here is a perfect square trinomial already to begin with that we could reduce this way, just go on and do the steps for completing the square. It will work the same way. Because at this point here we would square root both sides. These would cancel, leaving me with x minus 3 is equal to plus or minus 1. The square root of 1 is 1. And then we can add 3 to both sides, which gives us x is equal to 3 plus or minus 1. Any questions on this here so far? We're good with this here? Can I add 3 and 1 or do 3 plus 1 and 3 minus 1? Yes. So we do have to simplify 3 plus 1. Well, 3 plus 1 is 4. 3 minus 1 is 2. Now, since we got whole answers on this one, whole number answers, we don't have any kind of decimal. I could have gotten everything on the same side, so we could have subtracted 1 at the beginning to set it equal to 0 and graphed it, and the graphing calculator would have told us the values are 4 and 2. It would have told us that already. It would have told us that straight out. Any questions on this here? How do we feel with this completing the square? We getting the hang of each of these steps? Yes? Do we need to see another example of this? Because if we're feeling comfortable with it, we're gonna do more. We're gonna do more of these, but I'm gonna change it up just a little bit. Do we feel comfortable with this here? Yes. Okay. I'm going to move on to this one here. So we're skipping the next two because I feel like most of y'all feel comfortable with these. Yes? If you want to try them on your own, let me know. I can give you the correct answers to them. But this here is the other type that we're going to look at. So let's just get right into it, solving it, finding what value of x will make this 0. So our first step is A1. No. So since A is 1, what does our kind of step say? Is A equal to 1? If not, make it so. How can I make 3, the 3 in front of x squared, be 1? I'm going to divide it by 3. But I can't just divide it by 3. I have to divide everything by 3. Each and every single term by 3. Well, 0 divided by 3 is 0, so that's nice. 3 divided by 3 gives us x squared plus 12 divided by 3 would be plus equals. Now, it might be very tempting when we look at this here, hey, this thing will factor. Not quite. Because our middle term is going to add together. The factors of 5 will add together because it's the same sign. Well, 5 and 1 would give me 6. So it's not that the solutions are going to be not real, like our imaginary. They just might not be rational. They might not be rational solutions. So factoring wouldn't work. I'll tell you graphing doesn't work because they give us really ugly decimals. So we're going to need to use completing the square. First step, now that we have a equal to 1, we would need to move the constant over to the other side. So I would need to subtract 5 from both sides. Oh, this one is imaginary, so there's that. Once we move it, we still need to leave a space to put a number back in. Now, my next comment that I'm going to make is nothing important, but kind of as you were thinking, I know you were thinking it, but you don't always have to add it to both sides when we put c back in. This is one way to just keep things balanced. Because there are other equations we'll eventually deal with where, let's say 6x we can add and subtract it to the same side. We can add and subtract it to the same side because really I'm adding 0. We add and add this to both sides. We add the c to both sides because if, I'll write it up here so if someone's rewatching this, I'll do it this way here because if we have it set equal to something, that negative c, I'm going to have to add it over to the other side. It's going to have to move to the other side. So with completing the square, we just add it to both sides instead of add and subtract to the same side. And if you're wondering when we would need to add and subtract it to the same side, that would be finding equations of circles, which we won't cover. That's a higher level that we won't cover with this. So you don't have to worry about that. So getting back into this here, we just need to find the value of c next. Well, c is going to be what? B over 2 squared, and the value of b is 4, yes? And it would be positive. Well, 4 divided by 2 is 2, and 2 squared is 4 and 4. So we're going to have x, and what else inside the parentheses? Plus 2, yes, is equal to, well, negative 5 plus 4 is negative 1. So after completing the square, we get x plus 2 squared equals negative 1. Any questions on this here so far? So what do we need to do next? We need to square root both sides. Well, the square root and square will cancel, leaving us with x plus 2 is equal to plus or minus. What is the square root of negative 1? It's what? I. The square root of negative 1 is I. It's always going to be I. And last but not least, we need to subtract 2 from both sides, which gives us x is equal to negative 2 plus or minus I. And we can split it up if we need to. Big Ideas Math is probably going to ask you to split this into 2 parts if we want to do it that way. Any questions on this here? We good with this here? I mean, heck, most of y'all probably thought, I mean, having a equal something different than 1 would have been bad, yes? This isn't too bad, is it? Well, let me okay. But we're not going to deal with anything where a really doesn't divide into all 3, unless it's like a bonus or kind of a harder question I throw on the test as a bonus. But most of them are going to work like these here that we have. Okay? Any questions on this here? We're going to do 2 more. We're going to do 2 more of these, this one and one other. Yes, sir? I is second decimal. So if you notice on the graphing calculators, as kind of a side note, anything written in blue above the numbers is second. And anything written in green is alpha. So they kind of color coordinated that for you. Now, if there's something you know the graphing calculator will do, if you do second, let's see here, 0. Do you see where it says catalog? Like you've ever dealt with a catalog of any kind of company, how it's pretty much everything they sell. So if you look at the Nike catalog, which is probably as thick as a phone book, because if you actually got the true catalog of every single product that Nike ever sells, it'd be pretty hefty. That's what that pretty much the equivalent for that calculator is. It lists out every single function it can do. So you'd have to scroll through and find it. So I is second period, second decimal. And on a test, if you forget how to do that, just ask. I will tell you how to type that in. All right, so let's look at this one here. So this one here, okay, good. Is A equal to 1? Is A equal to 1? No. So what do we need to do? We need to divide everything by negative 3. Well, negative 3 divided by negative 3 would be x squared. And negative would be a positive 6x. And then we have plus 2 is equal to 0. Any questions on this here so far? Okay, so what do we need to do next? We need to subtract 2, because again, we need to get the constant terms on the other side. We need to get x squared and x on the same side. So we need to subtract 2 from both sides. Because these here will cancel, and we get x squared plus 6x. We've got to leave space. Negative 2 plus blank. Any questions on this here? Any questions on any of this here so far? So, now that brings us to the point of finding the value of c. So c is equal to b over 2 squared. What's the value of b? 6. Well, 6 divided by 2 is 3, and 3 squared would be 9. So x squared plus 6x plus 9. I think we had that one earlier, didn't we? Now, our set of parentheses would be x what? X plus 3. And negative 2 plus 9 would be 7. So that finishes up with pretty much most of our steps. We just need to solve. So we square root both sides. And I take the square root of both sides. The square root and square would cancel, leaving me with x plus 3 is equal to plus or minus the square root of 7. Any questions on how we got to this point here? So what do we need to do last? We need to subtract 3 from both sides. It tells us x is equal to negative 3 plus or minus the square root of 7. And we can't simplify this any further without turning it into a decimal number, because there's no way to add and subtract negative 3 in the square root of 7. This just doesn't work. Questions on this here? Any questions on anything we've done so far? We're good with this here? Yes? This is the last one we're going to cover. Now, I think for most of you noticed that these here, for the most part, are the same steps we had yesterday. They might be worded just a hair different. Yes? Except this is added, yes? Because I added the fact that we need to get x squared and x terms on the same side. So this here is fine. This, as we have it set up here, is perfectly fine as it is. We don't need to manipulate anything. Because our step number 2 was to get the constant terms by itself, yes? Are the constant terms by itself for this one here? Well, yeah, they're already over on the one side. So it's done step 2 for us. We don't have to add the 68 to both sides, then do stuff and move it back. We can leave it there. So let's kind of work through it. Well, first step is a equal to 1. Well, no, we need to divide everything by 4. And when we do that, we will get x squared plus 8x plus, I'm going to leave a space, equals negative 17. And because the constant term is already over to the other side, it kind of did step 2 for us. It already has the constant term on one side. Do y'all see that there? Yes. Now, if it works out that the variables, we had variables on both sides, we have to get all the variables on one side and the numbers without a variable on the other. We have to split them up for completing the square. Now we need to find the value of c. We need to find the value of c. C is going to be our b over 2 squared. And the value for b for this problem here is, would be 8. . 8 divided by 2 is 4. And 4 squared is 16, so we add 16 on both sides. So inside our parentheses, we'd have x and then what? Plus 4. X plus 4. Well, negative 17 plus 16 is negative 1. Last two steps. The first one would be 2. Square root both sides. And the square root and square would cancel, which gives us x plus 4 is equal to plus or minus I. And then we would need to subtract 4 to both sides, or from both sides. And that's it. That's all we need to do for this here. Any other questions on this here? Any questions on this here? We good with this here? Now, when we started this problem here, when we divided everything by negative 3, that feels like that should be changing something, yes? Kind of changing what the problem is. Let me make sure I have them typed in correctly. Yep. What I went on and did was graph these here. So the one in red, this here is the graph of the original function we were trying to solve. Negative 3x squared minus 18x minus 6. Now, let's see if I can. Now, the one in blue is the one after we divided by negative 3. We made that change. Now, most of the graph is different. Would you all agree with that? Because the blue one is now opening up, the red one's opening down. There's a lot of stuff that's different. This doesn't go down as far as this one went up. The red one went up way farther than the blue one goes down, yes? So what is in common? Look at this here. They still intersect the x-axis at the same place, don't they? And what are we trying to do when we solve it? We're trying to find the value of x that would make the function equal 0. We're trying to find the x-intercept. We're trying to find where it crosses the x-axis. So even though the rest of the function changed, where it crossed the x-axis didn't. Did y'all see this here? That's why when we divide or multiply by a scalar, a number through everything, it's not changing it. The one thing we can never do with solving quadratics or any higher degree polynomial function is divide by a variable. So whenever we're solving this, we can never divide everything by x, even if it has that in common, because it's going to change it. The variable, if we multiply or divide by a variable, it will change the value. So any questions on completing the square? We good with this here? Now, completing the square, we said, is one of the ways that works every time. No matter what quadratic we have, quadratic equation, and quadratic equations always come in the form of ax squared plus bx plus c is equal to 0, because we have them in this form. If we use completing the square, it will give us the solutions every single time. It doesn't matter what it is, it will always work. Well, I'm going to do it to this thing here, this general equation. Well, our term in front of x squared is not 1, so I divide everything by a. And you don't have to write all this down. Over a equals 0. Well, our next step was to get the constant term, and that's just whatever doesn't have x for the other side. Now, the b over a to find c, well, we would do b over a over 2 squared, which actually works out to be b over 2a squared, which is b squared over 4a squared. squared over 4a squared. Now this thing here actually ends up, if we use, would be plus b over 2a squared, kind of like what we just did. And I will leave all the steps out of how we would actually combine those two. We get this here. Now, the next step in solving was square rooting. Well, those simplifying, we get x plus b over 2a. Over here, we're going to have plus or minus. I can't simplify the numerator, but the square root of 4 is 2, and the square root of a squared would just be a. And lastly, I would subtract to get x by itself, which ends up giving me this here. And we get to this point here. Now, I said there was 5 methods, and there's another method that does work every single time. That's the equation. The last one we're going to cover, and the last thing we're going to do, so tomorrow is the last, actually tomorrow's going to be the last part of chapter 3 we're going to cover before the test. It's quadratic formula. It's the quadratic equation. It's here. So the last way to solve quadratics is with the quadratic equation. And 9 out of 10 times, most people use this here. And it's a lot easier than completing the square. And this works every single time, because I went about getting it using completing the square. So this is always going to be a solution, because the completing the square always works. So this one here always works. But that's all.